Hi, my name is Renaya Graves. I was assigned section 1.5, number 8. Describe the parts of a homeostatic mechanism and explain how they function together. In order to understand homeostatic mechanisms, I felt that it was important to go ahead and give you the definition of homeostasis, a state of equilibrium as in an organism or cell maintained by self-regulating processes. So, when we talk about homeostatic mechanisms, keep that in mind. Now, in homeostatic mechanisms, there's going to be at least three components. There's going to be a sensor or receptor, an integrating center or control center, and an effector. Keep in mind, this is very, very important. So please pay attention. Now, in order to understand how they work together, we have to know what do they actually do. So the receptor is going to basically get the information like an environmental stimuli and send the information over to the integrating center. Integrating center is going to basically alert the effector. It's an area in the brain that will basically alert the effector. And the effector is going to basically try to fix or make modifications needed to maintain homeostasis because they receive the information from the integrating center. So I would look at it like going like a downward flow. You know, 1 is going to be receptor, 2 is integrating center, and 3 is an effector. You can also look at it as a flow. If you see a flow chart with it, you just look at the words and you'll know, okay, which way is it going? How is it running? There's different charts. So just remember 1, 2, 3, and you'll know how it flows and you'll remember everything. That's the simplest way I can put it. Now, in order to understand how they work together, we need to know what are the purposes or how does it, work. That's basically through positive feedback and negative feedback. So positive feedback is a device in which an output is heightened in order to maintain homeostasis. It is intended to speed up or quicken the output formed by a stimulus that has previously been activated. Now, negative feedback is just the opposite. It's a device that reduces output or action to bring an organ or system back to its normal range of operation. To understand the most common positive feedback example, it would be childbirth. Basically, in childbirth, pressure receptors encourage the release of oxytocin in the pituitary gland. Oxytocin causes contractions, and the pressure increases on the pressure sensors. After the child is born, the pressure receptors are no longer stimulated, and oxytocin production ceases. So that's like the most common way I can explain that. So when talking about negative feedback, we're going to go ahead and discuss blood pressure. Now, the way this runs is if a stimulus such as blood pressure basically rises, pressure sensitive nerve cells, which is the receptors, are going to send impulses to the brain, the control center. And the brain's going to go ahead and send the impulses to the effector, which causes the heart rate to decrease and leads to the return of normal blood pressure and thus restoration of homeostasis. Basically, like I told you, 1, 2, 3. That's how you're going to always remember, even if it's positive feedback or negative feedback. It's a pretty simple way that they work together, and their functions are pretty basic. I appreciate y'all listening and paying attention. Thank you guys so much.